this is the in the bubble there is a number, and this is the sequence to make this find this product. So this is the final loop. Okay, this is the answer for all the process until 14. So I will show you for one process for each part, for part A, part B, part C, and part D. So let's proceed to see how to fill this for each part. So for part A, and so for this I choose process number 3, which is rough mile. From the sketch given, in the bubbles there is the step 3, so I will explain about the step 3. The process number 3, which is the rough mile. Why we choose the rectangular pocket inside? So we have to refer to the appendix, which is this one. This is the miling process and sequence. So as we can see, this is the part, the number 3. So this is the part. Refer to appendix. So this is the part which is the rectangular pocket. That's why we choose the process number 3 is the rectangular pocket. So we go to the next part, which is the part B. So this part we have to refer to the appendix. This is the appendix, and for this process, for the cutting tool we choose the MEM nail. So and then for the description we choose the 20S20 10TT for the number 3, because we choose the number of insert is the 3 because we use the 3 flute. And then for the size DC dimension is 20 millimeter, and from this appendix, when we choose this one, and we can know the LF and LH. So the LF is 100 and the LH is 30. And next we proceed to the part C. So we have to fill the cutter material and so on. So from this we have to refer to this one, this link. So we have to fill this one, this link, and we want to calculate the fit rate. So first one, we have to change the measure in unit to millimeter, and operation is miling, and material is aluminium. The cutter material is carbide. We have to choose the carbide, and the cutting speed is the same for the rough mile, which is the 274, and same goes to the cut contour mile. For the hole we use 76, and we have to put the end mile diameter. The end mile diameter is 20, and then for the maximum is 6000, and the cutting edge is 3, and the chip load is, for the rough mile the chip load is 0.16, and for the contour mile is the chip load is 0.128. so we can calculate this one, and we get the fit rate, which is 2093. So same as the answer that given. So for part C also, for the estimate time, so for the machining process rough mill for the rectangular pocket inside. So we have to choose the length of cut. So we refer to the um, this one. So as you can see, the inside is 120. So as you can see, the length is 120 and the other one is the 100. So for this one, for part C, which is this when we want to make this when we want to calculate this estimate time, so we have to choose for this one, for the length we have to choose the longest length. So as you can see, this is 120, and this is the 100, so we have to choose the 120. So uh, for the feet, we take this one. So we have to calculate with the estimate time 120 divided by 2093. So for the time estimate time, we get the 0.057 minutes. So we move to the next part, which is the last part, the part D. So we have to sketch the graphic illustration. So this is the graphic illustration. So we see the how to draw this illustration. So this is the process to sketch the illustration. So we have to, when we draw, we have to refer to the 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 sketch given and finish. So that's all for this lab 2. So that's all from me. Thank you.